Hey folks, so for today we're going to go over how to use Kangaroo as a plugin for Grasshopper to look at different ways of producing form finding animations. So we'll be looking at how to produce surfaces that are similar to like tensile structures created by FryAuto. So he's created these very interesting kind of form-finding models that look at how you can study tensile structures through different materials. So he works with meshes, with chains. This is a study using soap to look at surface tension when constrained to a frame. And then we'll get into like some diagrams and things like that, and how to kind of simulate these effects in Grasshopper using different variables like anchor points or amount of tension or material type. So that's what this tutorial is going to cover. So let's hop into it. So I've got a couple things set up in this Rhino file and Grasshopper script. So we're going to run two different types of simulations. One is going to be a tension cable or net simulation. It's like a catenary structure. So something like this, but inverted. That's typically how these studies were done. The tension of the cable was done through gravity, so it hangs upside down, and then you freeze it and flip it over, and that's what gives you the form for some of these models. So we'll be looking at that as a start, and then the second form finding function we'll get into is actually dropping an object into a cloth as a way of deforming it that way. Slightly different operation, but both are working with kind of tensile models. So this is what the first one's going to look like. In Grasshopper, I've got a surface, and when I hit the play button to run the simulation, you'll see this surface sort of drop as gravity acts upon it. And it kind of bounces around until it settles into its final form, at which point you can bake the geometry out and use it as a tensile created structure. Okay. Right now this has a couple anchor points on it. We'll get into how to set those up, how to modify and change up things like that, but this is what the first simulation is going to produce. The second one we'll look at, we'll get into collisions. So you'll have a sphere hanging out above a surface, and when we play this one, the sphere is going to drop into our mesh. So I'll play this. That sphere is going to fall based on gravity. Then it's going to collide with the mesh and deform that mesh. And eventually it'll come to a point of rest. You can then bake out that mesh, and you have that formwork. Okay, so these models would be fairly difficult to model from scratch or by hand to get that kind of like perfect tensile strength or shape. So this is a really great way of like creating these sort of tensile structures. So let's reset this. You're going to see a couple other things in here. I've got 2 cameras. These have to do with V-Ray, so that's going to be sort of part 2 of this tutorial, is getting into using V-Ray as a plugin for Grasshopper to produce animations. So the form finding portion of the script is this in purple, and then all of this stuff are the V-Ray components to render out the simulation as a movie. Okay, same down here. So we'll rebuild this first so you can create the form finding simulation. Then we'll create this so that you can output the rendering, and we'll just kind of go from there. So let's get started. I'm actually going to turn off that simulation and turn off this, just so it's not slowing down my computer. Alright, so Kangaroo always works with meshes. So the first thing we're going to do is create a surface and then convert it into a mesh. And the density of that mesh determines the resolution or the quality of the surface. We'll get into that. And then you need to extract certain points and edges from the mesh so that you can apply forces to them, which come in the they come as what are called action or goal loads. So up in Kangaroo tab, you've got all of these different kind of goals, which are essentially forces and actions that act upon your mesh. So that's how you do the simulation. So things like gravity and anchors and loads, we'll start applying those to the mesh, and that's what makes it sag. And then you run those forces into a simulator that you can play and run, and then you can extract the mesh from there. So let's just hop through this real quick. So we're going to create a surface first. I'm just going to type, or just create sort of a box surface. Okay. I'll hold Shift just to make it a square. And then I don't want it sit it on the ground, in the air a little bit. So I'll do something like that and just kind of pull it up. So I need to reference that surface into Grasshopper. So I'll double click, type surface, and grab a surface node. Select the surface, right click, set surface. And then I'm going to hide that surface, so I don't need to see it anymore now that it's referenced in Grasshopper. Now we got to convert this surface to a mesh, because we need to, Kangaroo only works with meshes. So we're going to grab this surface mesh component, and we'll input by clicking and dragging into our surface node. And then we need to define a density for that mesh. So in order to see what this looks like, I'll open our mesh edges node. So by default, this mesh is subdivided into 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 grids, essentially, or a 5 by 5 grid. Now that's pretty low resolution, so what that means is when this thing starts to sag or deform, it's going to look really faceted. So we don't want that. We want it to be slightly denser. And that's done by changing the U and V values of your mesh. And these are just how many subdivisions you have along each edge of your mesh. So if I double click, and let's say I type 20 and hit enter. As a number slider, I want whole numbers, so I don't want any decimal points. And then I'm going to plug this into U. And then I'm I'm going to plug another one into B. I just did Control-C, Control-V to copy. And you'll notice now the mesh is much denser. So I'm going to set this to 12 and 12, but you can see how you can make it more or less dense in one direction or two directions. So I'll do 12, 12. The higher you go, the harder it is for Grasshopper to simulate your mesh, so you don't want to go too high. Alright, just kind of move that out of the way. So the next thing we need to do is call out points, edges, and another set of points so that we can create forces upon this mesh. Okay, so forces in Kangaroo are always applied to either edges or vertices. This is why you need to convert everything to a mesh. So what we're going to do is grab our Weaverbird vertices node. So you also need Weaverbird installed for this, both Kangaroo and Weaverbird. So I'm going to type in Weaverbird mesh. Let's see if it pops up. So I'm going to type a little bit more. I still don't see it. So you can go up to Weaverbird, extract Weaverbird vertices component. And we'll grab that. And we'll plug our edge into this. And that's going to highlight all of the points or vertices that are on our mesh. We'll be applying a load of gravity on each point. Okay. Then what we're going to do is grab a Weaverbird edges node. So Weaverbird's mesh edges, pull that down, plug that into there. And that highlights all of the edges as individual segments. So one edge, second edge, third, fourth, all the way through. And we'll be applying a load onto those as well. The next thing we want to grab is this deconstruct vrep. And what that's going to do is extract the four corners of our surface. So deconstruct vrep. So it's going to give us the face of the vrep, the edges, and the vertices. In this case, our vrep is going to be our primary surface. So I'm going to plug that into here. And if I type point and grab a point node, I'm going to plug my vertices into my point node. And you'll see that I have now extracted just the four corners of our mesh. Okay, and that's going to provide those four anchor points to our simulation. So now that we've got that information extracted, let's start setting up our goals so we can start to apply gravity to this thing. So the first thing we want is a show geometry. So you can go to Kangaroo and grab, let's see, this show node. And we want to make sure the base mesh shows in our simulation. So we're just going to throw that in there. So any piece of geometry that you want to preview while the simulation is running needs to be put into a show node. Then the next thing we're going to grab is an action load. So this is sort of applying gravity as a load to our points. And that can be found under, let's see, where's that one located? It's under one of these. So it's under goals point, because it's a load that's being applied to a point. Makes sense, so we'll grab that, plop it down. And so this input is asking for a point to apply the load to. It wants a vector, the direction. Basically, this is the direction of gravity. And this is the weighting, which we'll just leave this as default. So we'll plug in our points from our vertices. And then the direction, we want to make sure it's going in the negative z direction. So it's as if gravity is forcing itself downward onto our mesh. So I'm going to type unit z. And then by default, z is positive, which we don't want. So I'm going to grab a negative node, plug that in there, and plug that into our force. Okay. So we'll just let that kind of hang out. The next node we're going to grab is what's called a line length node. And this is what enables the mesh to start to sag when gravity gets applied to it. Basically turns each one of these lines or line segments into what's called a spring. And the spring, if you can imagine, what a spring does, when force gets applied to it, it lengthens, and then when force is released from it, it shortens. Okay, so you got to imagine like you're stretching a spring outward and then letting go and releasing it. So when force is applied to a point, it begins to stretch that line out, which causes the sagging of the overall mesh. So we have to have that node as well. And that's under goals line. And we just want this length line node. And so we're going to take all the lines from our mesh and plug them in there. And then it's also asking for a length and a strength. Okay. Strength is how much you allow the spring to tend to stretch when forces are applied to it. And length is just an overall length that gets applied to the line. So you can let it grow or shrink that way as well. So we're just going to create two sliders for this at a unit value of 10. Plug them in here. We're actually going to leave this at 1. And we'll leave that, let's see what we want to put that to. We're going to set this to like 2 for now. And we'll play around with these once we have the simulation up and running so we can see what it's going to do. Right? And then the final goals node that we need is an anchor node, which is going to tell those 4 corner points to stay fixed in place. So that's under our point group. We're going to grab anchor. And the anchor node wants a point, a target, which we're not going to use, so you can ignore that, and a strength. And you want to leave this as default. If the strength goes too low, then those points will start to sag. We don't want that, so you want to leave this really high. By default, it's set to 10,000. So we're just going to plug in the points there. And again, we're grabbing those 4 points from this deconstruct brep node. Okay. Then what we need to do is merge all of those goals into a merge node, which will then allow us to apply them all into our solver, which is how we run the simulation. So double click and type merge and grab this merge node. Now by default there's only 2, but you'll notice we need a couple more. So if you zoom in really close, you have these addition buttons, so I can add a third if I want to. So we're going to put our geometry into the first one. And then we're going to take the rest of our goals and stick them into the second one. So I'm going to hold Shift and drag each one of these into something like that. Okay. Now we need our simulation runner, which is this what's called step solver, and that can be found under main. We're going to grab step solver. Okay, so it's asking for our goals, which we've inserted into this merge node. So I'm just going to throw that in there. Tolerance, momentum, dampening, and sub iterations. You can ignore all of that. All we care about is this last little command called animate, and we also need a timer. So in order to animate this, it's basically just a true-false command, so I'm going to double-click and type boolean. And I want this boolean toggle. And that's going to allow me to double-click this and switch it between true and false. So if I double-click it to true, it's going to run the simulation. If I double-click it to false, it will reset and stop the simulation. So I'll leave it at false and plug this in. I'm not sure if anything's really going to happen if we play this right now. So you see what's happening? It's kind of like freezing. That's because we're not telling this how often to run the simulation. So we need what's called a timer. So I'm going to double click and type timer and grab this timer. And I'm going to click and drag out of the right. And you'll notice if I hover over the step solver node, it sort of snaps into the bottom. So I'm going to snap it and release. Then I want to right click on this interval and set it to 20 milliseconds. So it refreshes the simulation every 20 milliseconds. Now if I play this, it should run the simulation. And so right now I'm just anchoring the four corners. So this mesh, based on the amount of gravity I'm applying, based on the anchor points, and based on the line or the tension I apply to each line via that spring or load length command, this is sort of its final resting position. Okay, so if I come back to these sliders, if I up the strength of the spring at each edge, it won't fall as far, right? Because if I'm raising the strength, it requires more force to pull those springs apart, and so there's a lot less tension in our model. Okay, so you can change the shape of the simulation or of the final mesh that way. And you can also rerun it every time, so I can refresh it by clicking true and false. And you'll see how that changes. So what I'm going to do is I'm going to select all this, middle mouse click, turn that off, so we can see what's actually going on here. Okay. You can add a slider to the amount of gravity if you want to change that. So now there's more force being applied and less force being applied. Typically don't do this, but you can if you want a little bit more variation or control out of how the model reacts. Okay, so that's how you set up a simulation using Kangaroo for Grasshopper. So the next thing I'm going to show you guys is how to change or pick custom points used as anchors. So right now, by default, I'm using the 4 corners, but I can change that around. I don't have to use those 4 corners. When you're defining your anchors, so let me reset this, you have to use a point that aligns itself with one of these points that is already on your grid. Okay, that's key. If I've got a point living like in here, it's not going to work as an anchor point. It has to attach to one of these vertices. So what I'm going to do is I'm going to grab all of those vertices, not that one, let's grab this one, right, all of those points. I'm going to bake them out from this node. And now I can select in Rhino all of those points. And I know, because I baked them out from this node, I know that they coincide with those points. So I can use any of these points as anchors. Right? So I can create a point node, right click, set multiple points, grab 1, 2, 3, 4, hit enter, and now those points are referenced in the Grasshopper. I'm going to hold shift and include those points into the anchor node. Okay, and then I'm going to run the simulation again, and it's going to account for those points being used as an anchor. Okay, so now it's kind of holding up that inner mesh area, right? And you get a slightly different shape from that. Okay, so one of the interesting things you can do is do a bunch of different shapes by using different anchor points and run the simulation over and over again and produce a whole library of different types of tension models, different forms. You can get into vaults, you can get into all sorts of different tension surfaces. So that's one way you can really work parametrically with this kind of method. Okay, so I could select, say, those 4 points, set multiple points, and you always want to refresh the simulation after you set new anchors, just to make sure. But I'll get something a little different that way. Alright, so I'm actually going to go back to those 4 middle points. I think that looked a little better. So I'll do set multiple points. And we've got that there. Okay. So that's a quick, easy way of doing these tension studies using Kangaroo. The next thing we're going to get into is producing a much smoother looking surface, which gets into Weaverbird again. So we're going to grab 2 nodes, this clean tree node, and then we're going to grab a Weaverbird Catmull-Clark subdivision, which subdivides the surface and makes it look a lot smoother. So I'm just going to double click, type clean, get this clean tree, and I'm doing this because the output of our step solver includes all of the things that were merged into here. So it includes all of the vertices, all of the edges, these points, this mesh, all of it. I just want to extract the mesh. So I'm going to input this into here. What you'll notice, it's going to give me the mesh up at the top, and it just kind of cleans up, gets rid of a whole bunch of things. So I just like to throw that in there. And then once you create this, it duplicates the mesh, so you can turn this off, and you can turn this off. That way you get a much cleaner preview from Grasshopper. Then what we're going to do is, this isn't a really smooth mesh. You can see it's like looking pretty faceted. So we're going to grab a Weaverbird Catmull-Clark subdivision, which is a mesh smoothing operation. we'll plug that into here. I'm going to turn off this clean command, and you'll see now that it's a lot smoother. It's not quite as smooth as I want it to be. And I can turn on my mesh edges node so you can see how it's making that mesh more dense, which makes it look smoother. I'm going to create a number slider with 3 values in it and plug that into L, which makes it even more dense. Okay, 3 is a little high, it doesn't need to look that smooth, so I'm going to knock this back down to 2. And you'll get something that looks like this. Alright, so that's a nice, smooth looking mesh. Delete that. And we can rerun the simulation and see what that looks like. Not bad. Okay. One thing you'll notice, the smooth mesh command is rounding over these corners. Okay, we don't want that, so I'm going to, under S, right click, and set this to corner fixed. And you're going to notice it's going to square off these corners for us. That looks a little better. Okay. And then now when we play this, those corners will actually stay fixed to the points. Alright, so that sets up the simulation. So I'm just going to group all that, Control-G, and turn that into our simulation group. Okay, part 2 of this is setting up an animation. This is kind of a cool new technique that V-Ray has created for Grasshopper, where rather than doing still renderings, we can actually produce animations of this simulation playing. And so that's what all of these components are, and that's what these cameras are. Okay, so this camera is what I'm rendering through, so we'll set that up. It's got a point telling where the camera lives in space, and then it's got a target point, that's the point that the camera's looking at. So we'll set all this stuff up, and then run the simulation. I'm just going to select all these points and hide them so they're out of the way. And then I'm going to turn off these anchor points, so we get a nice clean preview. And then I'm also going to pause the simulation while we work on this. Okay, so after you install V-Ray, automatically you should get this V-Ray plugin tab pop up for Grasshopper. And so let's start kind of rebuilding all of these components that allow us to produce the animation. There's a lot going on here, but the nice thing is once you set this up once, you can just copy and paste it into any script that you want to animate, so you don't have to keep doing it over and over again. So the first node we're going to grab is this render node. So we'll come under our V-Ray tab, under render, and I believe it's V-Ray render. So let's grab one of those. So there's a ton of inputs that we need to go through and kind of set up. Alright. You'll notice these get extracted. So in order to run through and extract some of these so we can see the options, we're going to right click and do extract parameter. So we're going to do that under each one of these. Then that will allow us to choose the options for these parameters. Okay. So engine, CPU is fine. This is just how your laptop renders, what hardware it uses specifically to render out the image. Then we're going to look at mode. We're going to leave this as interactive. This allows us to preview the rendering before we actually render it out. sampler. I believe this has progressive. Again, this is just so we can preview things. And then quality, we can set this to high, just so we get a nice animation out of it. The next thing we need to extract is the out image, and this is going to tell V-Ray and Grasshopper where to save our images. So I'm going to double click on this. I'll navigate just to my desktop and create a new folder. And call this Kangaroo Animation. You can name it whatever you want, doesn't matter. And just click name it Animation and click save. So that's where it's going to save all the images as we render them out. Output resolution. This is the size of your image. We're going to set this to 1920 by 1080, which is the standard size for any video. So right click, set multiple integers. Width is on top, so 1920, height 1080. Delete that. 1920, enter 1080. And click commit changes. So now our output resolution is 1920 by 1080. The next thing we need to input is our camera, and that's this guy here, so we can determine what we're looking at when we render this out. So we're going to grab a V-Ray camera node. So we'll go under render and grab a V-Ray camera. Now by default, the minute I create this node and drop it down onto our canvas, it creates a camera that matched the position of what we were looking at in Rhino. Okay, so it just kind of creates it wherever your current viewport is set to. But we're going to move it around. Okay. I'm actually going to turn this stuff off just so we don't see it anymore. Camera type, we're going to extract this parameter. So you have a couple different camera types. Basically, we're going to be using orthographic, which is how you set up an axon view. Standard is perspective view, so I'm going to switch this to orthographic. Stereo, we don't care about that. Position. This is done as a point. So we're going to define that point. So I want the camera somewhat close to our geometry, and I want it sort of looking down at it at kind of like a 45-degree angle. So I'm going to set this kind of up in the air in relationship to our plane. I'm going to grab a point node, set point, click our point, reference it in the Grasshopper, and plug that into there. And you'll see it moved the camera to that point. Okay, same thing with target. I want another point node. And this is what the camera is going to be looking at. So I want this point put roughly center of our plane. And I want it pulled down a little bit just because I want it to be centered when the cloth deforms and drops rather than centered up here. And you'll see why in a bit. So I'm just going to kind of set it right about there. And I'll reference that point into target. So now you can move these points around in Grasshopper, and you'll see the camera kind of updates as you move it around. So that's how you change what your camera is looking at. Okay. Field of view, don't care. Tilt, don't worry about it. Orthographic zoom. This is kind of an important one. It allows you to zoom in and out, so you can zoom closer, further away from your geometry. And so we're going to take a number slider that is set to be from 0 to 0.1. I believe, just make sure that's what I have this set to. Yep, 0 to 0.1. just going to type 0.1, enter. Now I want this to be, I want to be able to get all of the values in between 0 and 0.1. So I'm going to double click and set my digits to like 4. And that allows me to grab all of the values in between 0 and 0.1. Set this to 0.1. Click OK. Now we're going to put that into our orthographic zoom. I'll show you guys what that does in a minute. Exposure, don't worry about it, and the rest of these you don't need to worry about either. So that's pretty much it that we've got set for our camera. So then we're going to come in from our camera node and into the camera input of our render node. Okay. Light rig. This is where we start to set up the lighting for our scene. Okay. We're going to define our light source based on what's called an HDRI map. And so what we want to do is grab under lighting, we want a V-Ray light rig dome. Okay. And so light on, true, I'll leave that alone. Visible, we're going to set that to false. So I'll create a Boolean toggle. We'll want this set to false. And I'll explain that in a minute. And then our texture. So how HDRI lighting works, you can search HDRI image. HDRIs are images that you load into your 3D modeling software that provide a light source and reflectivity based on the image that you import. Okay, so if I wanted like a daytime rendering, I'm going to use a daytime HDRI map, and it's going to pick up all the light, it's going to pick up all the colors, it's going to pick up everything that's in that HDRI. So this is a really powerful way of producing light, realistic light for a scene. Now I've already got, you can usually find these for free, and I've already got a couple of them saved on my computer. So we go to documents, I think I have it under a Maya folder. Yeah, so I have a bunch of HDRIs that I downloaded for free. I'm going to be using this Derelict Highway. It's always been a good one. You guys can search these. I can also provide them as a link to this tutorial, so I'll include the description down below so you can have access to these. So what we're going to do is I'll extract that parameter, double click it, and navigate to that HDRI. And you always want to make sure you get the right image. So this is just a preview as a JPEG file. This is the actual HDRI image. So the image type is high dynamic range image, so that's the one we want. Click open, and now that's set. Now we have intensity, which we're just going to set to 1. So we'll create a number slider from 0 to 10, set this to 1. This is just how bright your scene is. And we're not going to worry about rotation or BG intensity. Just leave those the way they are. And we'll plug this light rig into our light rig. Okay. That is enough lighting for our scene. We don't need to add any more, so I don't worry about it. But you can add all these other kind of lights if you want. Okay, you have rectangle lights, sphere lights, directional lights. These would go into this little light input that's next on the list. But I don't care about that. VGeo is your V-Ray geometry. So this is the geometry that you want to render. It's going to be thrown into here. And that's going to come from our Weaverbird Camel Clark. Right? So if I run the simulation, I want to render out this mesh. Okay, but you don't plug it straight in. We have to apply a material to it. So we're going to grab this VGeo node, which I believe is under here. Nope, it's under here. So V-Ray geometry. Plug that in here. And this V-Ray geometry node asks for our geometry, material, and whether or not it's visible. So we do want it to be visible, so I'm going to create a Boolean toggle. Set this to true. Plug that in there. Now material. We're going to extract this parameter. So right click, extract parameter. Actually, that's not what we're going to do. We are going to grab a material preset node. So under materials, we want a material preset. Okay. This is the parameter we're going to extract. And it's going to give you a couple of different options. So generic, plastic, paint, metal, and glass. You can use metal because it picks up reflections really well. And we'll plug that into here. And then we need a color. So I'm going to double click and type color. And we're going to get this color picker. And insert that into there, which allows us to change the color. So then I'm going to take our mesh and insert it into the geometry input of our VGeo. So this will now have like this greenish colored metal surface applied to it when we render it. I'm going to take this and import it, or insert it right into VGeo. And now we should be able to create our renderings. Now that we've got all that set up. So, if I right click and do render, you should get a little rendering menu that pops up. So let's see what happens. Okay. And so what's happening right now is I'm way too far zoomed in, right? I'm just looking at like a little corner of our mesh. So what I'm going to do is I'm going to come over here and I'm going to zoom out using our orthographic zoom factor. I'm going to zoom out, zoom out, zoom out until I can see the extent of our mesh. Okay, so something like that. And now I'm like looking too far down. So I'm going to grab that target point in Grasshopper, or in Rhino. I'm going to pull that up until this thing is kind of centered on our screen. Now this is also set at a really strange angle, so I'm going to kind of pull this over a little bit so we're not looking directly at it as a 45, and I'm going to pull it down some as well. Let's see if we can pick a better spot to preview this at. Maybe something like that. And so what's going to happen is I'm going to zoom out and I'm going to toggle our animation, or our kangaroo simulation. So I'm going to turn this off, and you're going to see the base plane that it starts at, and when I turn this on, you should see this play. Okay, so that simulates. And then what we're going to do is render this out as an animation. Right, so one thing you can do is, now that that's settled, if I want to render this out as just a single image, I'm going to close this. I'm going to right click and stop the render. So I'm going to render this out as a single image. So I'm going to switch this to production and switch our sampler to bucket, right click, and render. What that's going to do is produce a final quality render as an image. And by default it's a PNG image type, which is what we want. So now if I navigate to that folder where we saved all of our images, I can open up that image, and I get this nice rendering of our catenary cable structure. Okay. Now I don't want just a single image, so I'm going to delete this. Close this. And we actually want to render out an animation, not just a single image. And that's where this timeline component comes in. Okay, and we're going to use this timeline component to animate our step solver. Okay, and so there's a couple different things. This is probably the hardest part of dealing with V-Ray, is setting up this timeline component, so I'm just going to kind of take this nice and slow. But what you want to do is grab a V-Ray timeline, and this is the number of frames that are going to be rendered out for your animation. So you have to determine how long you want the animation to play for. And so I want this animation to last, let's say, 3 seconds. Okay, so normal animations are played at a frame rate of around 24 frames per second. That's a little bit on the low end. More typical ones are around 30 frames a second. So if I want an animation that plays for 3 seconds at 30 frames a second, I need 90 frames. So I'm going to double click, type 90, hit enter, set that into our frame. So we now have 90 frames at which to render. Okay. Now for some reason this starts at 0. I don't want it to start at 0. So I'm going to set this right because it goes from 0 to 89. So I'm going to set this to 91. So I get that full 90. Okay. And then we'll just leave it there. Alright, so that determines how many frames are going to be rendered out. Now frames, basically V-Ray is going to render a single image for every single frame of our animation. So it's going to render out 90 images into that folder that we defined. Then we'll take those images into After Effects and compile them into our animation. So what we're going to do now is we're actually going to delete this toggle and delete this timer. And we're going to plug the frame into our animate node. So we're basically replacing the Boolean toggle with this time slider. So what you'll notice now, instead of double clicking on our true-false command to run the simulation is going to run based on which frame is in our animation. Okay. Now, one thing you're going to notice, it sort of ends the animation at like frame 30, and then from frame 30 to frame 90, it really doesn't do anything. So that's not what we want. So effectively, what we want to do is slow down the simulation. So it plays for the full 3 seconds or full 90 frames instead of just the first 30. Okay, so that's done with this sub iteration tab. So right now by default this is set to 10, which means it goes through 10 iterations every frame. We're going to lower that to 1 iteration every frame. So I'm going to double click, type 1, hit enter, and plug this into our sub iterations. Now when I scroll through this slowly, it takes much longer to play that animation. This gets a little tricky, and you might need to play around with it, render it a few times before you get the timing right, because what you'll notice, if I scrub this really quickly, it doesn't go very far. But if I scrub it really slowly, it does the whole thing. It's kind of a weird thing. Basically what's happening is the more powerful your computer is, the quicker it can render each frame, which means the less amount of time is given between each iteration. So if your computer's rendering super fast, it's as if I scrubbed that really quickly. If your computer is rendering really slow, it's as if I'm doing this really slowly. Okay? Most computers, and if you're on a laptop, are going to render it something like this. Okay? But you never really know until you actually render it out how fast it's going to render each frame, so you might have to test it a couple times and see how it works. But typically, if you set your sub iterations down to 1, that's kind of where you want it to be at. Okay. So now that we've got this set, we want to take this timeline output and input it into this timeline node on our V-Ray node. Okay. And what that's going to do, if I now right-click on render, I've got this render animation action available now. So I'm just going to save this real quick. Always save before you send an animation. So now, if I hit the render animation button, and you want to make sure that your mode is set to production and your sampler is set to bucket, because we're actually rendering out all of the images. When I right click and hit render animation, it's going to start rendering out each frame. So click render animation, and it's going to start in its starting position with a flat plane. Then as it renders out each frame of that 90 frame sequence, you'll slowly start to see this thing deform and change shape as the animation or simulation plays through. So I'm not going to let this go for every single frame. You're going to see that each one is taking between 10 and 15 seconds. So that it's going to take a couple minutes for this thing to finally render out. So I'm just going to hit escape and close out of this. I've already rendered this out, so I'm going to kind of skip ahead to looking at the images that were finally rendered out. But basically what's going to happen is it's going to start to drop those images into that folder you designated here, the out image, and it's going to give you 90 images, and we have to then compile those images in After Effects. So right now I let it render out like 3 of the images, so I got animation 0, 1, 2. Okay. So delete those. And then let's show you guys what the final images look like with them fully rendered. Okay, so let's take a look at the images that resulted from our animation. So I let all of those render out, and this is the library of images that it's produced. Okay, so from frame 0 all the way to frame 90. And you can kind of scrub through these just through your preview, and each image will be of this thing dropping. Okay, and it's a pretty decent rendering. The HDRI map, you'll see it gives you all of these reflections in your material. And that's why I use a metal material, because it's glossy. So it picks up those reflections, and it picks up reflections of the sun that comes from that HDRI map. So in order to complete the animation, what we need to do is use After Effects to sequence these into a playable movie file. So I'm going to save our Rhino file, minimize this, and open up Adobe After Effects. Okay, so I'm not going to really get into After Effects all that much. We're just going to use it real quickly to create that animation. So you can close the intro window that pops up. I'm just going to load those images by double clicking in this area over here. And I'm going to go to Desktop, go into that folder where all of those images are saved. And just as an FYI, The images for this animation are the only things that can be in this folder. You can't have other images, you can't have other files, it just has to be these images. So we're going to select the first one, and then you just want to make sure sequence options PNG sequence is checked. Now this might say JPEG sequence if you rendered out JPEGs, but you should always be rendering out PNGs so there's no background to the image. And so you just want to make sure that's checked, so you only select the first one, you don't need to select all of them. And go import, and it's going to import that as an image sequence. Down at the bottom you have your time slider where we're going to load our media, and it's going to create a preview of our video up at the top here. So I'm going to click and drag our image sequence, drop it down in the bottom over here, and we've got this playable video file. Okay. For some reason, the background of my video canvas is set to pink. If you want to change that, you go up to composition settings, and you can change the color. So I can set it to black, gray, white. I kind of like the pop images, so I'm actually going to leave it. Yeah, this is kind of like light pink color. It gives it good contrast between the object and the background. And then you can use your time slider here to kind of scrub through and preview your animation. If you tap the spacebar, it's going to play it real time. And so that's what our final animation looks like. You kind of just want to make sure that your animation fits on the screen, it's not getting cropped off, so it gets really low. So it's not really centered. You notice the distance here does not equal the distance down here. So I'm just going to take this animation using my arrow keys, I'm just going to like pop it up a little bit so it's a little bit more centered on our screen. Okay. So that's our animation. Now we just need to export this out to a video file. So I'm going to come up here. You'll notice the minute I drag and dropped our images down here, it created this dropped cloth composition. This is our actual video file. So I'm going to select that, come up to composition, and go to add to render queue. Click that. It's going to pop up and change our menu down here by default. So we want to click where it says output module, where it says lossless. I'm going to click on that. It's going to open up a submenu. And I'm going to switch this from AVI to QuickTime. That should be animation, and click OK. It's just a file type, don't worry about it. Just use QuickTime. Click OK. And then if you click the out to, we can save it to our desktop and give it a name. So I'm just going to leave it as drop cloth and click save. Then we come over here and click the render button. And it's going to render out that video. Alright, so I can now minimize this, and we've got our video file. Now the problem with this, the .mov video files aren't really playable on a PC, and you can't really upload them to Instagram or YouTube or anything like that. And you can, but it's just not a very popular video file. We choose it because it tends to compress the video a little bit more, so it's not a huge video file size. You want to keep these as low as possible, but you don't want to lose the quality of your video either, so we choose .mov. And then the next step, so this is actually playable, is to bring it into the Adobe Media Encoder, and then we'll convert it to what's called a .mp4 video file, which can be pretty much shared and previewed by anybody on any computer. So we'll just open this up. Again, I'm not really going to get into this. There's not much we need to do here. We're just going to click and drag our .mov movie file into this area here. Release. Give it a second to upload. These options, you just want to make sure this is set to H.264. This is a compression video type. High quality 1080 HD. And then you can click this here to save it. And this should say video file.mp4. Save, and then click the green play button up at the top. And it's going to render out that video. Now that went really fast because it's only 3 seconds. Sometimes they take a lot longer. We'll close out of this. And now we've got that playable video file. Okay. That's pretty much all there is to it. Like I said, it takes a while to set up the first time, but once you've set it up once in Grasshopper, you just copy and paste that whole thing. And you don't have to create all of this from scratch every single time. Just select it, copy it, paste it to the next Grasshopper script that you want to animate, set your camera, set your settings, lights, all that kind of stuff, and then you'll be good to go. So the next thing we're going to jump into is the second script. And again, I'm just going to go over this part here. All the V-Ray stuff, that's all the same as we just did it. So we'll just kind of cover how to create a object that actually collides with our surface, which is this collision mode, so we'll get into that next. Okay, so let's hop into the second script, which is getting into what are called colliders, so we can show how this ball drops into the surface and actually collides with it, forces it to deform. Okay. So again, I'm just going to rebuild this part up here, and then I'll show you where to input the slider so that it actually shows this thing coming down and dropping into the cloth. And you can animate that. And all of these things, this is the exact same settings that we did up here. So you just literally just copy and paste it for the next animation. And then you just have to set your camera and make sure it's looking at the right thing. So let's get started with this. I'm going to turn off all this stuff so you can see it. And just like our previous script up here, we're going to start with a surface in Rhino. So I'm just going to create a rectangular surface. Just kind of move this inward. Move it upward a little bit. Okay, we need to reference that surface into Grasshopper. So I'll select the surface, right click, set surface, and then I can hide that surface in Rhino. And then we're going to convert that surface into our mesh, just like we did before. So I'll type, double click, type surface, mesh, or I guess it's mesh, surface, and input, drag into our surface node, or into our surface input. And then we want to define our U and V. So for this, I'm going to go condense. I'm going to do 20 and 20. So I'm going to link those together. And you can use a single slider if you want it to be even. So again, preview that with our mesh edges node. You can see what that density looks like. Super dense or less dense. Around 20 is fine. And turn off our preview node or our surface node. Okay. And then again, like before, we need to extract the vertices and edges of our mesh so we can apply forces to them. So we're going to grab, again, our Weaver Bird edges and our Weaver Bird vertices. Vertices and edges. And then we can start setting up our goals again, like the actions and forces up in the similar, up in the previous one. We're going to be doing the same thing down here. So we're going to set up, first of all, we need to set up forces for our mesh, which are going to include a show command, so we can preview the mesh. It'll have the length line action, so we convert those segments into our springs, and then we're going to anchor the 4 corner points. Okay, so let's grab our rolls in. So we want our line length, we want our point load. Nope, we actually don't need our point load. We don't need a point load for this because we're going to use the ball to deform the mesh rather than gravity. Okay, the gravity is going to act on the ball. We'll get into that in a second, but that's why we don't need a point load for this mesh. But we do need our show goal so we can preview the mesh, right? And then our Weaver Bird edges are going to go into our line length, so we convert all of the edges into our springs. Okay, so we've got those two set up. And then we need an anchor. Okay, so I'm going to anchor the 4 corner points again. And I can do that, so I actually don't we'll need that for later, so I'll keep it there. But in order to grab those 4 corner points, again, we're going to deconstruct that surface. Deconstruct brep, which gives me the vertices, the faces, and the edges of this base surface. Turn it off. But all I want are vertices, so I'm going to point node and extract those vertices so you can see I'm grabbing the 4 points. Okay, and then I'll put those into our anchor. Okay, so that's all we need for our mesh. Now what we need to do is define the ball up in the air. Okay, so for this, we are going to create what's called a mesh sphere. Okay, which is this guy right here. So what this is asking for is a base plane, which is where the sphere is going to be located based on its center point. It's going to ask for the radius of the sphere, the number of faces in the U and V direction, so basically the density of our sphere. So let's get that set up. So in order to define our base plane, we're going to create a point in Rhino. I'm going to move this point so it's roughly centered on our plane, but then located above our plane. So we want the ball to drop from a starting position that is above our plane. So I'll reference that point into Grasshopper, attach that here, and you'll see our sphere is now located on that point. Now the sphere is really faceted, so the next thing I'm going to do is add to the U and V value to make it a denser sphere. And you'll see the resolution of that sphere is now quite a bit nicer. And then we want to modify the radius so the sphere is a little bigger. So create a number slider and plug that into there. Or not that big. Yes, like that. Okay. And I don't want this to take forever to drop into the cloth, so I'm actually going to move this down a little bit. Set it like there. Something like that. Okay. So we've got our sphere, right? Now we need to tell the sphere to drop according to gravity. So right now if we were to run the simulation, it would just kind of stay floating in space. So the goals, or the forces for our sphere, there's going to be a couple different ones we want. So again, we want the line length and we want our force, so this is going to tell us to have gravity push the sphere downwards. And we want what's called a rigid body, which tells the sphere to not deform when it comes in contact with our mesh plane. That's really important. If we didn't have this, the sphere would deform and squish depending on the collision properties between the surface and the sphere. So we want the sphere to maintain its shape, okay, so that it doesn't change. So we're going to have a rigid body force. And then we're also going to have a line length force as well. So let's pull all those in. So again, just like we were doing before with any mesh that you're using in Kangaroo, you need to extract the edges. So we're going to use Weaverbird for that. Grab our Weaverbird mesh edges. We also need our Weaverbird vertices. We'll plug those into here and here. And then let's grab our goals. Okay, so we'll go back into Kangaroo. So we want a point load on our sphere. Right, so we grabbed all of the vertices. And we plug that into here. And again, we want to set up a negative Z value. So the sphere drops downward. So we'll grab a Z unit and a negative value, string those together. And then I'm also going to create a number slider so I can change the amount of gravity that's being applied to it. We'll just set this to something like that. Okay. So our force is set. Now we want to set up our rigid body. So we're going to come under, I believe that's under point. Let's see. Let me just have this. So here we go. So under the first menu, we want this rigid body set. And that's going to be, let's see what goes into that. So our vertices are going to go into our rigid body as points. And then we're going to bring in our mesh as our part. So it's asking for a part, which is the mesh. So that'll go into there. And it wants our points that define the rigid body. So we're going to grab our Weaverbird vertices, put that into there. And then the strength by default should be set pretty high. It's set to 300. So let's right click, or we can set up our number values to 300 and plug that into our strength. So those points stay as a sphere. Okay, they're not going to deform at all. Or at least they should when we run the simulation. Alright, and then the third thing we need is our line length. Let's see, so Kangaroo for this, goals, line length. Same thing as we used before. And again, that's going to come from our Weaverbird edges. So we'll put that into there. And we'll just set these. Let's see what we set them to. And I just kind of messed around with these settings until I got it to look at what I wanted. So this is set to 0.01, and this is set to 10. So we'll just use those again. So we'll do 0.01 and 10. Okay, so now we've got our forces for our sphere. So our mesh is set up so that it will deform when the sphere drops into it. And our sphere is set up so that it will fall into the mesh and the sphere itself will not deform. Okay. So the last goal that we need before we set up the simulation is our collision goal, which tells the sphere to deform the mesh as it intersects it. So we want this solid point collide goal. So we're going to come up under goals collision, solid point collide. Keep a set of points outside or inside a given mesh. So what this is going to do is it's going to tell Grasshopper to keep all of these points outside of this mesh, so that as this mesh drops, rather than intersecting the mesh, it's going to push all of the points away. It will not allow the points to intersect or get into the inside of that mesh. So let's set this up. Okay, so the inputs for this surface or solid point collide, it's asking for points to affect. It's asking for a solid that's going to keep the points out of. So solid is going to be our sphere. Interior, if false, points will be kept outside the solid. If true, they will be kept inside. So we want this set to false because we want the points down here on our mesh to be kept outside of our sphere. Unidirectional, if true, the mesh is used only as input, not itself affected by the collisions. We want to keep this as true, I believe. Just double check that. Oh, we're going to set it to false. So that both the mesh and the sphere are accounted for when we run this simulation. So I'm just going to type Boolean toggle false. Put that there. And then strength is set to 1. Let's see what I ended up making that 200. Okay. So we'll kind of mess around with that once we get the simulation going. But for now, let's just set this to 200 and click OK. Or I can do a number slider and do 200. So our points are going to be coming from the vertices on our mesh. So I'm going to bring in that there. And then our solid is going to be our mesh sphere. So that's going to go there. So we should have all of our goals set up for this. Okay. So then the next thing to do is to merge all of those together. Okay. So we'll grab our merge node. And we'll start plugging these in. So again, the show geometry. We actually want to create a show geometry for our sphere as well. So we'll take that and put it into there. Add that in there. Alright, so the two geometry nodes, show geometry commands go into the first merge input, and then all of these, hold shift, are going to get put into the second. Okay. And then we want to grab our simulation step solver. So main step solver. And again, we'll grab our timer. Set this to 20 milliseconds, plug it in. Grab our Boolean toggle, plug it in, and then R goes into our goals. Now that we've got that set up, I can come back and just turn all of this stuff off. We don't need it anymore. Actually, you know what? We probably don't need this show because we've got our rigid body set up. So I think that replaces it, so we're just going to delete that. Because this rigid body node acts as our show geometry node. So that takes care of that. So now hopefully, if this is all set up correctly, when we run this, the sphere should fall into the mesh and start to deform it. Yep. There we go. And then depending on the strength of the sphere, and the amount of gravity, and the strength of the mesh, it'll eventually come to a resting point. Reset this. So I don't want to see all of these points and all of that stuff. So I'm going to clean this up like we did before. So I'm going to grab our clean tree, put that in, and grab our Clark subdivision to smoothen our meshes over. So that's under Weaverbird, Clark, and throw this into here. And now I can turn all this stuff off. And I've only got my sphere and mesh. So again, I'm going to set this to corner fixed to square off our corners. And I'm going to set this to 2. And let's play this. Kind of get a better look at what's going on. Okay. Now if you don't want it to sink that low, you notice how the ball is almost like starting to fall through the sphere. It's because you would just have too much force going down on it, and Kangaroo doesn't really know how well to simulate that, so it's going to start to lose it eventually. So what we're going to do is come back to, let's see, let's go into our string. Anchor should be fine, line length. Let's see what I set these line lengths to. 10, so that should be fine. It's just a matter of figuring out which of these to modify. Let's lower the force of gravity. That's a little better. If you lower the amount of force being pushed down on the sphere, it's not going to tug on your mesh as much, and it might come to a more reasonable stopping point. But you can mess around with that and change it. And again, you never really let the simulation run all the way through. You can bake this out at any moment and extract that geometry as a surface. Right? Obviously, you don't want the sphere as geometry. So one thing that's kind of strange, right, is that the sphere at some point kind of pokes through the mesh surface. We don't want that to happen. So what I'm going to do is scale that sphere inwards a little bit so it doesn't intersect our surface like that. That's just a preview thing. Grasshopper can't compute it well enough to maintain the look of the sphere always being inside the mesh. So all we're going to do is call out that sphere. So I'm going to grab a dispatch, because right now within this we've got 2 pieces of geometry. One is our mesh and one is our sphere. So I want to set that out to being a sphere in one of these nodes and the mesh in the other one. So I'm just going to flatten this So I have one mesh here, and then I need to figure out which one is which. So I'll put that there, put that there. So now I can select each one individually. We can turn these off. So I want the sphere. I'm going to scale this uniformly. So I'll scale the sphere. When you scale something uniformly, we need to define the center point of scaling. By default, it's the center of Rhino, which we don't want. That's why the sphere is way over here now. So we're going to grab a volume node, plug our mesh. So we're going to take the volume of our sphere, which by default gives us the center of that sphere. And so the output center is going to go into the center of our scale. And that's going to allow me to scale that sphere inwards. So I'm going to turn off this mesh. And then our scaling factor is going to be the value between 0 and 1. So 1 being full size. And then I'm just going to scale this down so that it looks like it's inside the mesh rather than outside of it. Okay, so that's just a little preview trick to keep the ball inside the mesh. So now if I were to replay this, the sphere up here is a little smaller, which is fine. And it's going to come down and drop in. And when you render this, you won't really notice that gap, but the sphere will never end up outside of the mesh. Okay, so you can effectively drop any kind of object into your mesh if you want to change the way shapes are being created. So instead of a mesh sphere, I could do a mesh box. Let's see what it's asking for. Let's disconnect that. Base box. So let's create a box in Rhino. And I'll put it relatively close to the sphere. And then I'll do right click, set one box, and create that box using the box we created in Rhino. And then we can hide that. So now instead of the sphere, I'm going to have the box drop into it. So let's see what this looks like. Okay, so it's got quite a few points on it, so that's good. So anywhere this mesh sphere is referenced, I'm going to reference this box instead. To make that a little easier, I'm just going to create this mesh node, plug that into there, and let's keep that turned off, so that's good. And let's replace each one of these. So replace that, that, and that. Let's see if this actually works out. So I created this little mesh node, so now that anytime I create a mesh primitive or shape, all I have to do is switch it out here, rather than switching it out in every single one of those spots. So let's hide this, and let's hide that. So we've got our mesh box. Let's see what happens when this thing falls into it. Hopefully this works out okay. It should start to collide and deform that mesh, and we'll get a slightly different shape out of it. So if I come over here, right click on this mesh, right, because that's the mesh being deformed, do bait, click OK. We're going to get a slightly different shape out of it. Okay, So you can start to mess around with like dropping different shapes into the mesh as a way of creating different types of surfaces that way. Right? So that's pretty much all there is to that type of simulation. Now in terms of animating this thing, like I said before, all of the V-Ray stuff is the same. You just have to determine where to place your time slider and what moment that goes into your collision or to your simulated script. And so I'm going to turn all this stuff off and let's see where the best spot is to put it into here. So let's turn you on, that on, and I believe so we're going to do the same thing we did before, where we delete our two controllers for our step solver. We're going to make sure our frame is set to 91. We're going to plug in the frames into our animate. Now what you're going to notice is that from 0 to 91, that sphere is dropping way too slow. It'll never make it to the end of the animation or the end of the simulation in just 90 frames. It just doesn't get far enough. So we need this to happen quicker. In the previous version we wanted it to happen slower. So for this one it should go quicker. So what we're going to do is this sub iterations. Last time we set that down to 1. Now we're going to pop it up to 10. Plug that in. And now that sphere should drop a lot quicker. Okay, and if you need it to happen faster, you can set this to be a lot higher, I believe. So let's set this to like 20. And now that sphere is going to drop. It's basically just running the simulation a lot quicker. So again, this is one of those things where you're just going to have to mess around and time it out until you get it right. But you're basically just messing around with your timeline. You want the number of frames to stay consistent because we want it to play for 3 seconds. Again, if you want it to play longer than that, you can add frames. And then you change the sub iterations to run the simulation faster or slower, depending on how quickly it's playing. Alright, so that's pretty much everything. Mess around with this, change the shapes that you're dropping into this thing. If you really want to get into it, you can add more than one shape. There's tutorials on how to do that on YouTube. And then mess around with the anchoring methods for the first one. You can create different anchors. You don't have to use a square mesh like this. You can use rectangle meshes. You can do all different kinds of things. So yeah, have fun with it.